Hey there everyone! Today I thought I would present this Arduino project that I've been working on with a group of friends for uni. Basically, this project controls a simulated traffic light and pedestrian signal system. It's pretty cool what you can do with an Arduino to create real-world tech. Alright, so before we begin, I'd like to go over how I've set this up. So basically, we've got this, a potentiometer. This will be controlling the brightness of these LEDs. This set of red and green will be the pedestrian LEDs, and this is an RGB LED, which will be switching between red, yellow, and green. And this will be controlling the traffic. This button, you can treat this button as the same button you press when you cross, and this is a 7-digit display. This will be showing how much time the pedestrians have while they cross. And obviously resistors. These resistors, if I click on them, you can see how much resistance is in each of them, as you can see. All of this hooked up to the Arduino over here. That's the basics of it. Now let's get into the code. Let's take a look at the code. You begin by defining the pins connected to the various components on the board up here. For instance, RGB traffic pin red is the pin connected to the red LED on the traffic light. There are also several global variables that track the system's state and timing. This controlling the intervals between the lights switching on and off. This controlling the numbers that pop up. Another example, the current state tells us the current state of the traffic light. And button already pressed here, check if the button has been pressed. Moving on to the setup, we initialize the pins from earlier with the LEDs here being shown as outputs and the button here, which will be controlling the LEDs, this will be an input as shown here. Now you may be wondering what this serial begin 9600 means. Basically, this prepares the Arduino to convert data and set up the baud rate with a number here representing the bits per second. Now, the print status function starting here is a very long function which will be controlling what is called the serial monitor, which is this terminal down here, although it isn't on right now, as well as the segment display on the physical board. The code is mostly made up of serial print lines and cases, which allow us to create multiple scenarios based on how the Arduino is interacted with. For example, this section, labeled current state, uses the variables stated before up here and will show in the serial monitor whether the button was pressed or not and the current color of the traffic lights, whether it be red, green, or yellow. You can see another situation similar to the one above for the pedestrian lights, except this one only being red or green, or flashing red. This long section of code, which just looks like a bunch of orange blocks, is what controls the 7-segment display. And each case here represents a different number, as we can see, 987 goes to 0 to 9. And each of these lines represents a segment on the display, and the low or high tells it to be on or off. Okay, now let's explore the loop function, which is the heart of the project. This function basically runs continuously and handles everything from toggling the pedestrian lights to managing traffic light sequences and adjusts the LED brightness based on the potentiometer. If I tried to explain everything, we'd be here all day, so I'll try to stick to the most important parts. This bit here uses the potentiometer variables to control the brightness, which is 1023 being the maximum value it can input, and these three numbers here being the RGB values, except for here it is RBG for some reason. This section here is pretty cool. It actually locks you out of the system unless you input a specific password, which we've set up here as V. So if I input V into the serial monitor, we can see that the serial monitor starts running. And now if I press the button on my Arduino, we can see that it says the button has been pressed and the system starts. Now the rest of the code is mostly just a set of cases with the millis function managing how long each light needs to be on for. Lastly, we have this little bit of code here. This just tells the Arduino to switch the LED colors when it needs to, and it's sort of a shortcut. Okay, so here I've brought up the schematics for the Arduino, and this schematic is a hardwiring diagram of the traffic light system, which was made by Tinkercad, this website that we used to set it up. As you can see, the Arduino is here in the middle, and it's all connected to the LEDs and the resistors showing off, the push button, 7-segment display, all here. So this flowchart basically explains how the traffic system code works. The start of the flowchart begins by asking whether or not the password has been entered, and it then goes down and goes through whether it has time to print from either pressing the button or if it has been 2 seconds since the button has been pressed. The flowchart continues and asks whether the input is 0 or 1, which handles the application of the SSD and then blinking red pedestrian LED. It then asks whether the button is pressed, and if so, the sequence begins. The sequence is followed using a switch statement, which goes through yes and no statements to determine the current state of the sequence and to input the correct LED to light up the brightness of said LEDs. This process will then repeat itself for each state and is looped until the Arduino is terminated. Another thing I wanted to quickly go over is the difficulties my group faced as we made this code. A lot of the issues we faced were mostly revolved around the potentiometer, trying to change the brightness of the LEDs according to the values we got. At the start this was kind of hard, but we eventually got it to work by using a separate switch state, specifically for inputting the brightness of each LED in the states. Working on this project as a team rather than individually kind of forced us to get together and discuss our roles for each task more, trying to minimize issues and figure out who did what and how they did it. Another thing, this traffic light system code was an easy upgrade from the previous assessment that we did by completely implementing Melis functions and not having delay functions, as well as using analog reads and analog writes to allow the potentiometer to change the brightness and to print the analog value. Alright, so before I go, I thought I'd just demonstrate the traffic system in action. So I'll press the push button and I'll let it roll. This controls the brightness. As you can see, it slowly dims. Turn it back up. Now the light will turn to green. And we can see the 7-second display showing the timer. Now it goes back to red. And soon the traffic LED should go back to green. There you go. Thank you for watching. Tune in next time.